So we have learned how to solve quadratic equations by graphing. We've learned how to solve them with factoring. And today we're going to do square roots. Just like factoring, this has some limitations. Remember, graphing is not very accurate, but we can see exactly where the zeros are. Factoring, we can obviously only do it when it can be factored. Sometimes you can't find two numbers that add to make this and multiply to make that. Square roots limitations is it only works when b is 0. Remember, we have y equals ax squared plus bx plus c. We can only take the square root when there's no bx term, when b equals 0. So, chances are you guys know about square roots, you know about perfect squares, but one thing that we leave out until we get to this part is every positive rational number has two square roots. One is positive and one is negative. This is because if we take the square root of 36, we need two answers, 6 and negative 6. Because if we go backwards, the opposite of square rooting 36 would be squaring. 6 squared gives us 36, but then also negative 6 squared gives us 36. So because there's two options that we square and get 36, that means when we take the square root or do the opposite, we also have to have two numbers. So when solving equations with squared variables, we need to remember both square roots. So if we have something like x squared equals 81, we need to take the square root of both sides to undo that square. So that's where this part comes from. But to find all possible solutions, we need to find both square roots. So we need this sign right here. Remember that sign is plus or minus. So we have positive or negative options. So we have plus or minus the square root of x squared has to equal plus or minus the square root of 81. So we take the square root of x squared and we just get plain old x. Take the square root of 81 and we get 9. And then we usually don't write the plus or minus on both sides because we can simplify it to just positive 9 or negative 9 works. So you have to remember the square root. You have to remember that there are two options. So let's do some problems. So the very first one, I have x squared plus 5 equals 5. Before we can take the square root, we need to get the x squared by itself. So what I want to do to both sides is subtract 5. And then once I subtract 5 from both sides, we get that x squared by itself, and it equals 0. So then to get x by itself instead of x squared, we need to do the opposite of squaring, which is square rooting. So if I take the square root of x squared, I just get x. And then we have to remember plus or minus. We have two options. But we have plus or minus 0. There's no such thing as positive 0. No such thing as negative 0. So for this one, we only have one solution. 0 is the only option. So if we were to graph this, it would only touch the x-axis once. So let's do the next one. Next thing I need to do is get x squared all by itself. So this part's all opposite operations. I want to add 49 to both sides, and then I'm left with 16x squared equals 49. And then the next thing I need to do is get rid of that 16. So I'm going to divide both sides by 16, and we are left with x squared equals 49 sixteenths. So you always want to simplify when you can. We cannot simplify 49 sixteenths, so don't type it in your calculator just yet. We need to take the square root to undo the square. Let's take square root of this side, square root of that side. Square root of x squared is x. We need to remember plus or minus when we're solving this. And then also remember that the square root of 49 over 16 is the same thing as the square root of 49 divided by the square root of 16. And those are two numbers that we can simplify easily. So that means x equals plus or minus square root of 49 is 7, square root of 16 is 4. So positive 7/4 works, and also negative 7/4 works. So the awesome thing about graphs like this is your x-intercepts are exactly opposite. And that's because your axis of symmetry is 0, because B is 0. Pretty awesome how that works out. The next one is interesting. We got to get x squared by itself. So subtract 49 from both sides. And then divide both sides by 100, just like we did before. And we get x squared equals negative 49 100ths. So just like the last one, don't simplify it just yet. Don't type it in your calculator. Let's take the square root and undo both sides. So the square root of x squared is x. We have to remember the plus or minus. And then remember that we can break this up. Square root of negative 49 divided by the square root of 100. Hopefully you saw this coming, but remember we cannot take square roots of negative numbers just yet because we don't know about imaginary numbers. So if you get this far and you are taking the square root of a negative, we can stop. And the answer is no solution. A graph of this would look like the ones where it never crosses the x-axis, somewhere like up here. So there's no number that you can plug in for x that's going to give you 0 out for y. So we had one of every option here. In the very first one, we only had one solution. So your graph would have looked like this. It should have just touched once down here. B, you had equal parts. So you had positive 7/4 and negative 7/4. And on the very last one, we had no solution because it never touches the x-axis. So let's do some estimation. Not all the time we're going to get perfect squares, and that's totally okay. Square roots can be estimated with a calculator, or we can leave it in radical form. After this chapter, in chapter 11, we are going to do some simplifying radicals, but until we get to that part, we're just going to type it in our calculator. So let's say I want to take the square root of 10. I could leave it as a radical, leave it as a square root, positive square root of 10, and then negative square root of 10. Or I can type in the square root of 10 into my calculator, and we get 3.16. That's an estimation, but it's close enough, especially if we were graphing. So let's do the next one. Same steps. We want to get x squared by itself before we can take the square root. Don't freak out about the negatives, because sometimes they work themselves out. I divide both sides by negative 3. I get that x squared has to equal 30. Not a perfect square, so we know we're going to get a decimal in our answer. But if I take the square root of both sides, square root of x squared gives me x. We have to remember plus or minus the square root of 30. So if it asked us to leave it like that, we could, but because it said solve and estimate, I want to know what the square root of 30 is estimated. So if we type it in our calculator, we end up with 5.477225575. So because we're estimating, let's do 2 decimal points. About 5.48. So if you were to check this or plug it in, you should get close to 0. Very, very, very close. If we were graphing this, it'd look almost right in between 5 and 6 where it crossed. So let's use that to do a story problem. This rectangle is twice as long as it is wide. The area is 578 centimeters squared. What are the dimensions? So I know inside of here is 578. I need the length and the width to multiply together to get area. Because remember, area is length times width. I don't know either of them. So let's make up some letters. When it says that it's twice as long as it is wide, we're comparing it to the width. So let's make that x. Twice as long would mean 2 times x. So we're going to plug it in that formula up there. We know the area is 578, and that has to equal the length times the width. And then let's simplify. 578 equals 2x squared. And now we get to solve for x. So I'm going to divide both sides by 2. We end up with 289 equals x squared. And then to get x by itself, take the square root. So we get x equals plus or minus 17. Now remember, this was a story, and we need to find 2 things. We need to find the length and the width. We have 2 options here for x. X could be positive 17, or x could be negative 17. But because this is a story, and x represents a dimension, we cannot have negative dimensions. We can't have negative centimeters. So even though negative 17 mathematically works up here, it doesn't work with our problem. So we can totally forget about that. And we can say that x, or the width, has to be 17 centimeters. And then we also have to remember to find the length. Don't just be done with the 17. The length has to be 34 centimeters. Quick double check. Is 17 times 34 the area that they gave us? And if you multiply those together, you get exactly 578. So, square roots aren't that bad. The next one, completing the square, is pretty tough. So, graphing, factoring, square roots. We only got 2 more, and then we know all the ways to solve a quadratic equation.